Hello ladies and gentlemen, welcome to the Test-Driven Development Techniques video tutorial part 2. My name is Vasily, I am a professional software engineer. In the first part of this series, we saw the simplest approach to test-driven development, which involves writing all the tests up front. While this approach is perfectly valid and widely adopted, it has some drawbacks. The main problem with writing all the tests up front is that we do not get any feedback until all the tests and all the production code are written. It makes the debug of failing tests harder and turns TDD into a boring activity. Luckily for us, there are more sophisticated techniques that address these issues. The second technique that we are going to see is based on the 3 rules of test-driven development that were stated by Robert Martin, also known as Uncle Bob. Uncle Bob's rules are: you are not allowed to write any production code unless it is to make a failing unit test pass. Rule number 2. You are not allowed to write any more of a unit test than is sufficient to fail, and compilation failures are failures. And rule number 3 is you are not allowed to write any more production code than is sufficient to pass the one failing unit test. It is alright if these rules do not make sense to you right now. They will become much more clearer once you see how I apply them in practice. So, suppose that we are still working on driving lessons registration system. We need to allow the registered students to schedule driving lessons with specific instructors. However, there are some constraints. First of all, instructors work between 8 a.m. and 4 p.m. Instructors can teach more than one student at a time. Instructors do not work on weekends, they're human after all. Instructors have additional vacation days. In order to manage instructor schedule, we are going to implement instructor schedule class. So first of all, create new package, call it scheduling. And inside this package, we implement a new class, instructor schedule. At this point, the first rule of TDD already kicks in. You are not allowed to write any production code unless it is to make a failing unit test pass. Since we don't have any failing unit tests right now, we must start writing them. We create a unit test and start writing test methods right away. When doing test-driven development, a big screen can be very beneficial. What I like to do is to split the screen in two, have my test on the left and the production code on the right. This way I can jump back and forth between the test and the production code without switching the screens or using my mouse. So let's write the first test method. Schedule lesson, start time before instructor start time, rejected. This method will ensure that if we attempt to schedule a lesson before instructors start to work, this lesson will be rejected. We create a test lesson set some fake ID, set some fake student ID, and now to dates. In this test class we are going to work with dates a lot. Therefore, it will be beneficial to extract some dates into constants at this point in order to make our life easier down the road. Right, I want it to be the next Monday, and I want to set hours to the instructor start time, and I want to set minutes to 0 and seconds to 0 as well. And of course we would like to have instructor start time as a constant. Great. So now we can schedule this lesson to start before the instructor starts, and let's say that this end date will be after the instructor starts. Great. And now we would like our system under test to have a method that returns boolean, and this method is called schedule lesson, and it takes the lesson as a parameter. And this test method will clearly not compile. Therefore, the second rule of TDD kicks in. You are not allowed to write any more of a unit test than is sufficient to fail, and compilation failures are failures. Therefore, the fact that this method will not compile forces us to start writing some production code. And the production code that we write is just some template for a method. And now I need to be very careful, because what I want to do is to write some more production code in order to make this method functional. But that will be a violation of the third rule. This rule states that you are not allowed to write any more production code than is sufficient to pass the one failing unit test. Therefore, since our unit test compiles and passes right now, we are not allowed to write any more production code, and we need to get back and write some more unit tests. So we can complete this unit test because we want to assert that the result is false, which means that this lesson, which is attempted to be scheduled before the instructor starts to work, will be rejected. And now, when this method is complete, we can actually run the test and see what happens. The test passes. Another moment to be very careful. We know that this method passed just because the current implementation of schedule lesson method returns false for all inputs. However, by the virtue of the first rule, we are not allowed to write any production code unless it is to make a failing unit test pass. And since there are no failing unit tests right now, we cannot write any production code. We need to continue writing unit tests. I am sure that many of you don't understand why would we like to write any more unit tests while the production code is clearly broken. But please be patient. It will become clearer in several minutes. Constrained by the first rule, we proceed to the next test case. Schedule lesson start time exactly instructor start time accepted. This test case will ensure that if the lesson is attempted to be scheduled at the start of instructor's workday, it will be accepted. I wouldn't like to write anything from scratch, so let's just go here and copy from the previous test case. Right, so we want the lesson to start exactly when the instructor starts, and we want the result to be true because the lesson should be accepted. After completion of the second test case, let's run the tests again, and voila, one of them failed. So at this point we can finally get to the production code and fix it. So return lesson get start date time dot get hours greater or equal 8, and let's put this guy into a constant. Rerun the tests. Both tests passed. Once again we ended with the production code, which is clearly incorrect. However, remember the first rule. You are not allowed to write any production code unless it is to make a failing unit test pass. We don't have any failing unit tests again, therefore we cannot proceed with writing any production code and should get back to the unit tests. Our current test cases ensure that lesson cannot be scheduled before instructor start, and also that the lesson can be scheduled exactly when instructor start. So the last test case that we need to add in this context is the one that will ensure that lesson can be scheduled after instructor start. So that will be +1 and that will be +2, and the test shall return true. So let's rerun it, and the tests pass again. All the tests pass. Therefore, according to rule number 1, we need to continue adding new tests. So we dealt with the lesson start time, now let's deal with the lesson end time. So we want the schedule lesson method when end time before instructor end time to return true. This means succeed. I just noticed one very unfortunate code duplication. This part that instantiates lesson for the test is being repeated in all the tests. Therefore, we should probably extract it to the constant. Right, so valid lesson starts when the instructor starts and +1, and maybe even change this name to date time. Cool, and let's get back. One more thing is that should be probably such that we can change it in our tests. And now we can write that lesson equals valid lesson with start date time with hour +1, and with end date time with hour +2, and change this to lesson. Rerun all the tests. All the tests still pass, including our last test, which passes only because there are no assertions in it. In this test we want to have a lesson that has an end date just before instructor ends its workday, so that will be 15. But this one, yes, instructor and time, right? and that will be 16. Minus 1, and we would like to have result and we would like to assert that result is true, because if the lesson ends before the instructor ends his workday, then this lesson is valid. Run the tests, and all the tests still pass, even though we know that our production code does not check the end time at all. We are not allowed to write any more production code unless we have a failing unit test. The next test case, no surprises here, will check that when the lesson ends exactly when the instructors end, it is still valid lesson. Exactly, succeeded, right? So the end time will be exactly instructor end time, and the lesson should still succeed. Run the tests. They pass. Next test case please. So this test case will ensure that if the lesson ends after the instructor ends, it should fail, rejected. So it will be +1, and the expected return value is false. Run the tests. Yes, finally, one of the tests failed. We can finally go and write some production code. So we would like to add some condition on the end time. End lesson, get end date time, get hour, smaller or equals to 16, which is instructor end time. Run the tests again. All the tests passed. You might be wondering at this point why I only check the hours. What about minutes and seconds? You are right wondering that. It looks like I implicitly assumed that minutes and seconds are not important. However, I don't like having implicit assumptions in my design. We need to make any assumption explicit. Therefore, let's add test cases that will ensure that the lessons can be scheduled only with minutes and seconds hard-coded to 0. So we want test method which, upon call to schedule lesson with minutes not 0, will throw an exception. Expected, let's say illegal argument. So what we want is a lesson with, for example, start daytime with minutes 1. And all we want to do is to schedule this lesson. That should result in an exception being thrown. Run the tests. Okay, exception is not thrown. So now we need to fix the production code. How do we do that? If so get start date time get minute not equal to 0, throw new illegal argument exception. Rerun the test. It passes. So we need to get back and add more test cases. The next test case will ensure that if the lesson start time seconds are not 0, then public schedule lesson, okay, start time seconds not 0, then exception is thrown. And let's fix the name of this method as well. That will be start time, because eventually we would like to test the end time as well. So with seconds 1, run the tests. The new test failed, therefore, according to Uncle Bob, we need to go and fix production code. So what we'd like to do is to add condition on lesson get start date time, get seconds not equal to 0. Also throw illegal argument exception, and rerun the tests. Superb. Right, and we will definitely want to add the same tests, but for instead of for start, for the end date time. And preserve the caves, thank you very much, replace all. Run the tests. 2 of them failed, right, those are the new ones. So we just add this lesson get and get minutes not equal to 0, or lesson get and get seconds not equal to 0. Rerun the tests. All tests passed. And that, ladies and gentlemen, is how we make implicit assumptions explicit in the code. Let's get back to the requirements. Until now, we used Uncle Bob's test-driven development technique in order to implement the first requirement and ensure that instructors work between 8 AM and 4 PM. We shall proceed to the next requirement and ensure that instructors can teach more than one student at a time. However, since this video already got past 20 minutes mark, it will be the perfect moment to make a break and delay further requirements to the next videos in this series of tutorial. So, thank you very much for watching, and if you like this video or found it useful, don't forget to like it and subscribe to our channel. See you next time, goodbye!